Maintenance practices for the environmental system consist primarily of inspection and cleaning. Since most of the system deals with air, filters are of considerable importance. There are several filters in the pressurization system, and each plays an important part in the function and safety features of the system. The pressurization system uses two filters. An internal filter is contained in the controller itself. An external filter is mounted nearby. Each of these filters must be cleaned in accordance with maintenance manual instructions. The outflow valve also contains a filter that must be cleaned as directed by the maintenance manual. The outflow valve itself will require periodic cleaning to prevent sluggish operation. The cleaning interval is specified in the maintenance manual, although in some cases a more frequent interval will be necessary. Since most aircraft no longer allow smoking on board, the cleaning problems with the outflow valve have been lessened due to the absence of nicotine and other smoke contaminants that can accumulate around the outflow valve moving parts. One consequence of not allowing smoking on board the aircraft has been that pressurization leaks are now less visible. The nicotine in cigarette smoke produces a brownish stain that is obvious evidence of a leak in the fuselage pressure sealing. Usually such leaks occurred around the doors because of door seal leakage. The door seal should be inspected and replaced as necessary. One of the key elements to preventing door seal freezing problems is proper maintenance of the door seal filter system. The drier portion of the filter contains silica crystals that must be replaced when they have turned pink in color. While recommended intervals are provided, the actual rate at which the crystals will need replacement will be dependent upon utilization hours and local environmental conditions. The environmental components in the wing center section should receive regular maintenance as well. Each time maintenance is performed in this area, the environmental components located nearby should be given a visual inspection. Leaks in the high-pressure bleed air plumbing will be evidenced by discoloration and charring of surrounding hoses and components. Usually, any leaks in this plumbing will cause the wing overheat light in the cockpit to illuminate. Because of the high temperature of the air carried in these lines, any evidence of a leak must be thoroughly investigated and repaired immediately. Leaks in the cold air duct system are harder to spot visually, but can lead to pressurization problems. A leak in the system may cause the thermal blankets that surround these lines to open or come off. It is also possible to check all of these lines for leakage during engine run-up, although care obviously must be taken to avoid the prop while walk-arounds are made. Components requiring maintenance in the cold air area include the water separator, which must be removed, and the sock cleaned at regular intervals. Again, utilization rates and ambient conditions will determine the exact interval. The cooling turbine must be lubricated if it's to provide its intended service life. Differing intervals are called for depending upon the model installed. Many operators have developed their own lubrication interval based on their experience. In any case, it is vitally important that the turbine be lubricated exactly as specified in the maintenance manual and with one of the specified oils. Within the turbine, a wick assembly is used to hold and evenly distribute the oil. This is the purpose of allowing the oil to soak in the turbine for 20 to 30 minutes before draining it. This is a very important step and should not be overlooked. Proper lubrication is a must for this component, not only because of its operating speeds, but also because of its high replacement cost. Located downstream of the cooling turbine in the cold air and conditioned air ducts are flapper-type duct check valves. These units should be inspected as they sometimes stick in the open position. While this will not be noticed during normal two-engine operation, a check valve being stuck open will prevent the aircraft from being able to maintain full pressurization on one engine if the stuck check valve is on the side of the inoperative engine. One of these valves that will be noticed during normal operations, if stuck open, is the unit installed in the fresh air fan. The check valves in the wing center section usually stick open due to corrosion caused by moisture in the cold air from the turbine. Corrosion damages the check valve surfaces or springs. The fresh air fan check valve is more susceptible to interference problems than moisture, since air flowing through it is usually not moisture-laden. The interference comes from the installation itself. If the fan assembly is removed for maintenance, the ductwork leading to the pressure bulkhead requires sealing. Mechanics sometimes overdo this, and sloppy sealer can become stuck to the valve's moving flappers, causing sluggish operation. When this valve eventually does close, sometime after takeoff, a noticeable pressurization bump will occur. Another problem sometimes associated with the environmental system are wing overheat warning lights and engine fire warning lights. Each of these can be caused by leaks in the bleed air system. Engine fire warning lights can be caused by a leak in the plumbing forward of the firewall. Wing overheat warning lights may be caused by leaks in the wing center section, or in some cases by running the cabin temperature control system in max full hot for too long a time. Most aircraft were modified with the restrictors installed to prevent this occurrence. Another related wing overheat problem concerns condensation. When the system is running at max full cold, all of the aluminum ductwork may begin to accumulate condensation, depending upon the ambient conditions. This sometimes leads to a partial short occurring at the various thermal switches, usually the one installed under the cabin floorboard in the tempered air inlet duct. This will be evidenced by the wing overheat light dimly illuminating or flickering, and eventually going to full on. Usually, moving the temperature control to full hot for just a few seconds will drive off the condensation and cause the light to extinguish. Proper sealing of these switches will help to prevent this occurrence.